This conference will now be recorded.
Okay, encapsulating. What is encapsule? What is a capsule? So capsule is something like it's a tablet which contains the small medicines in it,
Mhm.
and it will be wrapped with the plastic, right? Right?
It is
That is
wrapping of data into
yes. Data
object,
members into yes. Data objects together into a single unit, right?
a single
So
unit. Yeah.
yeah, if you see, encapsulation is nothing but wrapping up of data and data members together into single unit. We'll call as a encapsulation. We'll call them as an encapsulation. So the encapsulation will actually how it looks. Let me close this. Okay, the encapsulation is wrapping your data and data members together, and and it will not expose it will not expose themselves to the outside the world. So what we do, our data, which is a private, data members, which is public, we will wrap together and we will expose it. So whenever anyone want to make use of it, and whenever if anyone want to make use of it, what they will do, they will use these members, data members, which is a public, they will access it, they will use it, and they will actually make use of, and they will what I can say, they will use it. So for example, I have a class, and class has some private variables. So if they are private, they cannot be exposed directly, right? If they are private, they will not be exposed directly to the outside the world, outside of this class, correct? If I want to get these values, how will I get? So these values we will get, with the help of getters. With the help of getters. Do you remember we discussed this sometime earlier, like a getters? Getters are nothing but a public method which will retrieve the value. Setters are nothing but a public method. We will set the value. Something we will set the value and we'll get the value. Let's look at here. I have an encapsulate employee. So these are the data members, ID, salary, and these things. Okay. So by default, these values will be set it. These values will be set it. Will not be having any methods to set. Since they are private, if you want to make use of them, you will be having getter like this. You got it? Am I audible to everyone?
Yeah, Ravi.
Yeah, Ravi.
So encapsulation is nothing but wrapping up of members and member functions together. Wrapping up of members and member functions together. There is a shortcut to create getters and setters. I forget in this. There is a shortcut key to generate a setters and getters. I'll show you. I forgot the shortcut key. So it's coming. Why maybe it's Scala. It's not coming. It's not coming here. Okay. So these private members, right? If you want to, if they have to expose to the outside the world, outside of this class, we will have the getters. We will have the getters. So this we will call as a encapsulating, wrapping up of data members and member functions together, data members and member functions together, and that will be exposed outside the world with the help of the getters like this. Let's look at here. I have created an employee, which is encapsulated employee test. I'm setting the value. So I'm setting the value. Whenever I want, I can do the get it. Since they are private members, they cannot be exposed outside the world directly. They have to be exposed with the help of getters only. That's called encapsulating. Encapsulating. You can tell we'll call them as a POJO, plain old Java objects. POJOs, we'll call them as a POJOs. Okay, for example, let me show you here. I'll write some Java class. Look at here. I have a private members here. So these are my members. So what I will do, I will generate setters and getters. Look at here. In the scala it didn't come, but here it comes. Why scala didn't come, I'll tell you. Okay. So here getters and setters. Let's say I don't want the setters. I will generate only the getters. I will generate only getters for all of them. Like this, the getter methods. So I will generate here one constructor. I will generate here one constructor. Okay, this is a constructor. If your class name and your object, your class name and your the actually will call as a constructor. The class name as your constructor name should be same. The class name on this should be same. Then we'll call as a constructor. Okay, let's look at here. This is my Pojo class, right? This is my Pojo class. Let's look at here. I'm going to write one more class. Pojo test. In this Pojo test, I am writing my main method. I'm trying to create an object for the Pojo. I'm going to write a Pojo demo. So it is expecting 3 parameters. One is ID, another one is name, another one is salary. Okay. Now, as you know that since they are private members, they cannot be exposed directly. If I write like this here, I'm trying to print system.out.println means I'm trying to print. Okay, ID is, if I say pd dot, do you see apart from the methods get name, get ID, get salary, apart from these methods, do you have anything like a name, like ID, like a salary? They are not exposed. Correct? Yes or no? So why they are not exposing? Why they are not able to access here? They are private. They are private. If they are private, those members will not be exposed directly to the outside the class. So to access these values, we will use public methods. So here a simple example is these are the data members. These are the data members. These are member functions. These are the data members, and this is member function. What I'm doing here, wrapping together into single unit, that's called PD object. Then I'm trying to access those values. If you write like this, we'll call encapsulation. Is this clear to everyone? Rishabh, Frame.
Yeah, Ravi.
It's called encapsulation. What is encapsulation? Encapsulation is nothing but wrapping your data member and member functions together and accessing them. Okay, coming to, okay sir, you have shown me setters and getters in Java. Why not in Scala? Why not in Scala? If I come to Scala, if I write like this, internally, see in Java, I have to write this much big code. I have to write this much code in Java. But if you go with the Scala, if you declare a var, where will call variable in constructor, this is a constructor, right? If you declare a var, it means that var will have by default getter and setter together will be there. Var means you can be able to modify and reassign and able to access, right? What is the meaning of var? Var means you can able to set the value, you can able to get the value. That is a var. Variable, that's a variable, not var, it's a var, it's a variable. So variable means you can set the value, you can change the value, you can modify the value. No, variable means, but val means constant. You cannot change the value, you can only make use of it. Val means constant, you can only use it. So if you declare a variables like var and val, by default internally they will be generated setters and getters. There will be setters and getters will be generated in the background. Setters and getters will be generated in the background. Is this clear? You really no need
So,
to write
Ravi,
explicitly.
every data member that we will be having here should be val to get getters and setters. Otherwise, we won't
Yes.
have them.
No,
Okay.
see, the concept of the encapsulation is wrapping your
Mm-hmm.
data members and member functions together. That's the concept,
Mm-hmm. Yeah.
right? But the
Mm-hmm.
best example for the encapsulation is POJOs. POJO will call
Mm-hmm.
plain old Java objects. That's the best
Okay.
example. Okay,
Mm-hmm.
so that's the reason I have shown you POJO. Even if you write any
Mm-hmm.
object is an example of encapsulation. What are the object you are creating, right?
Mm-hmm.
Person object, employee object, whatever the object you are creating, that's a encapsulated object only.
Okay.
As per the definition, encapsulation means wrapping your data member and member functions together is is the encapsulation concept. Your object is already doing that.
Yeah, I mean, having the variables defined and the function within the same class, it's in encapsulation already.
Yes, it's already encapsulation.
Okay. So just for using them in the other classes and objects, we need getters and setters when the data member is private.
No, Rishabh.
That's the only
Yes,
difference.
yes, that's true. Correct, correct. If you
Okay.
have a class with the private members, if you want to access them outside the class, uh, through setters and getters only, you can assign it with the setters. You can retrieve it with the getters. Understand this, sir? Hello.
Yeah, yeah, Ravi.
Uh,
Got it.
Okay.
so Ravi, one more question I have. Like in case of val, also we can do the getters and setters, or like is there any other rule for
No, no,
that?
no, no. I was talking about a different context. Here, when it comes to the scala, right? In the
Mm-hmm.
constructor, if you declare a val or var, val means only getter. The meaning of val is you cannot reassign the value, right?
Okay, okay, okay. Yeah, got it.
Var means you can set the value, you can change the value, you can retrieve the value. So you remember that if you declare any variable with a var, it means you have option to assign, change, and all those things. If you have a val, so only getter.
Yeah, val will be constant and variable, like we can modify it anytime.
Yes, yes. Um, that also I'll show you. I just forgot how to see that. I'll show you in give me a second. Um, so when you compile the code, right, in the background, it will generate setters and getters. I'll show you an example. I'll show you an example. But it has to be compiled with a different keyword. No, not this one. Not this one. It has to be different. While compiling, you have to use a different keyword. Yeah, if anyone is interested on the Scala in deeper knowledge, I strongly recommend go through Alexander's book. Alvin Alexander's book. He's an author. Okay, he has written a book called Scala Cookbook. Look at here, Scala Cookbook. It's a really, really nice book. It's a really nice book. Hmm. If you see this, after compiling this, I think Java P you need to do. When you compile this class with the Scala C and then deassemble with the Java P. Okay, I think I can do this. Let me do this. I know. Okay, let me do this. I did it quite a long time, but I forgot. That's the reason. Let me do it now. Encapsulation. Okay. Okay. Java C or not Java C, it's a Scala C. Scala C. You guys know this, right? What I'm trying to do here? You guys aware or not? You guys remember Scala C means what? Very initial days before we using IntelliJ, we did that. Scala C for the compiling your
Compiling.
code.
Yeah, compiling
Yeah,
code. Yeah.
I'm going to compile this code, okay, using object this one. Okay, it is compiled. I can show you where it is compiled. I have to go to that path. That's the reason I'm just. Okay, it is compiled. Com, scala, encapsulation. This is compiled. Okay, so why these many are created? So what is this encapsulation demo? I understand. What is this person? What is this test pojo? What is this setters and getters? These are all part of your class. Test pojo, setters and getters, test pojo, person. These are all part of. These are all part of your encapsulation demo. So whenever you compile, right, a specific class, a specific object, how many classes are there in that file? How many classes are there in that file? All of them will be compiled and created a class files. Okay, let me do a Java P and setters and getters. Why it is not? What is the exact name? Setters getters dot scala class, not scala class.
Maybe the path
Okay,
is not correct
correct. Yes,
encapsulation. Yeah.
yes. We have to go inside this com and all this path. Here we can see. We can see what are the files are there. dir/p. It is a dir/p is the command line command. Okay, this is what I want to do now. Java P setters and getters. Setters and getters. It's not showing anything here. Let me do it a person. You look at the person. Okay, first look at the code. Person code. Person. Why setters and getters? There is no constructor here. Okay, that's what. There is no constructor here. Look at the person. Look at the person. I have a name, ID, salary. Is there anything else in this class? Display method is there. That's anyway. I'm not worried about the display method. Any other is there? Name. Is there any method with the name? Is there any method with ID? Is there any method with the salary? No, right? Now look at here. Look at this. Okay, person. Private var, val, var. Look at here. ID, ID, val. It's a val. ID method. Okay. Salary method. Salary, you have two methods. One, this is setter. You are setting the method. And this is the method to get. This is the method to get. And this is the method to get. These two are get. Salary, this is your passing a value means you are setting. What happened to name? What happened to name? Why there is no setter or getter? Why
Because it
there
is
is
var
no?
type variable.
No. Look at closely. Look at the closely. It's a private. It's a private,
Oh yeah.
right? For the private
Mm-hmm.
variables, this class cannot give you setters and getters. It cannot give you any setters and getters in Scala. In Scala, okay. If you declare a variables like this in the constructor in Scala internally, they use setters and getters. Okay, let's see one more. We have a test pojo. We have a test pojo. All are private. Test pojo. All are private. Let's look at what it shows. And this is the constructor. Okay, this is the constructor, and this is the normal method. Java P. Test pojo. Is there anything is displayed from the test pojo? Nothing. Apart from this, apart from constructor, none of the method is shown since they are private. Since they are private. Okay, I'll do one more thing. I'm removing this. Okay, I'll compile it again. So to compile, I should go 3 levels down. Okay, now I need to do scala C. Unless I'll use a arrow. Uncompiled it. Okay, after compiling, I need to go to 3 levels up. Com, scala, encapsulation. Now dir/p, I'll show you these things. So I have modified which class? Test pojo only, no? Let me Java P test pojo. You guys see the difference to above test pojo, below test pojo. This is above test pojo. This is above test pojo. This is below test pojo.
We have setters and getters for all the variables.
Setters and getters has been created for all of them. It means while you are creating a constructor, if you use a var, setter and getter.
Can
If
we
you use
use
a var,
protect and see?
okay, you want to try protect.
Yeah.
Protected. So can we do for only
Just
one
one.
variable?
Yeah. That's fine.
Okay. Private anyway we have already seen. Public by default, if you don't specify anything, it means public. For the protected, you have setters and getters created. Only private you cannot create. Clear? This is called
Yep.
encapsulation. This is called encapsulation. I forgot about the Java P option. Now I got it. Okay. So you got for everything, for every Scala in the background, it will generate a Java code. Since they will run on the JVM, it will create. Okay. Good. This is about encapsulation. Next one is polymorphism. Polymorphism. Can anyone tell me what is a polymorphism? Polymorphism. How many of you guys have practiced method overloading? Method overloading.
Yeah.
Method
Right.
overloading. Method overloading.
Mm-hmm.
Polymorphism. What is the meaning of the polymorphism? Poly means many. Morphism means forms. Many forms. Poly means many. Forms means forms. Many forms. Polymorphism. So it means it will have the same name different argument list, different argument data types, and it will be there many forms. It will be there many forms. That's called polymorphism. Polymorphism, many forms. Your method overloading is the best example for the polymorphism. Your method overloading is the best example for the polymorphism. And there is something called method overriding also. Method overriding also, what is this? Polymorphism only, no? Because same name, many forms, correct? Name is same, but many forms.
Yeah.
If you look at here, there are two types of polymorphism: static polymorphism, dynamic polymorphism. Static polymorphism, dynamic polymorphism. Static polymorphism is nothing but your method overloading and method overriding. Method overloading, your operator overloading. There are overloading methods, many forms. Dynamic means at the runtime it will identify. At the compile time it doesn't know what has been many forms. What has been many forms. For example, look at here, disk class. Go to a disk class. This is your disk. This is your disk, your parent. Your parent. Polyprintable, polyshowable childs. Display the parent. Display is the parent. Polyshowable, polyprintable. These are the childs, and they have overridden. Okay. And if I create like this, parent object reference, child object. Parent object reference, but a child object. This is called dynamic polymorphism. Dynamic polymorphism. Dynamic polymorphism. Static polymorphism is nothing but you have already seen. Method overloading, method overriding, these are all. But this is dynamic polymorphism. Dynamic polymorphism is nothing but your child parent reference is holding the child object. Any questions? Any questions?
So here disp is the parent class,
Yes,
and polyshowable and the polyprintable are child class.
child classes,
When
correct.
they are inheriting the disp,
Sorry,
I mean these two polyprintable and polyshowable are inheriting disp.
correct. They're childs of the disk.
Okay. So, Ravi, what basic difference does it have when we declare a object like this? Just like line 34, we are having data type as disp and the object type is polyprintable. So, uh,
Okay,
with
do one thing.
reference to the
Yeah, I'll do.
accessibility,
I'll do one thing. So we discussed about the inheritance earlier, correct? And
yeah,
also
yeah.
I have shown similar kind of example. The parent can hold the child. Parent reference can hold the child object.
Hmm.
1 second, please. 1 second. Hello. Yeah, tell me. సరే రండి ఇంట్లో ఉన్నాను నేను మీటింగ్లో ఉన్నాను ఫస్ట్ ఫ్లోర్ ఐ మీన్ మీటింగ్ okay. So here the parent reference object is holding the child object. The parent reference is holding the child object. Okay, do one thing, guys. I'll give an assignment. Okay, same assignment. You keep it. Disk. Yeah, you keep there. Disk is a parent. Disk is a parent. Correct. Disk is a parent. Yes or no, guys?
Yes.
Yeah.
And polyprintable, polyshowable are childs. Okay. Now
Yeah.
I have overridden the printable. I have overridden the show. In one class I have overridden this. In one class I have overridden this. Okay, look at here. Printable I have overridden here. Show I have overridden here. Now if I 1 second, please. Now you guys tell me which object will be created, which method will be called. Printable is in parent. Printable is in parent as well as in child. Which will get called?
The object one.
Which object? Parent
I
one
mean
or
the
child one?
polyprintable. Child one. Child one.
Child one.
I am from printable. I am from printable. Okay, let's assume that.
Mm-hmm.
I don't have here. I don't have here. If I don't have, you should not write override. Now you tell me which one will be called. Now you tell me which one will call? Parent or child?
Still, it will call child only.
It will give an error.
Oh.
It will give an error because at the compile time, that's what I'm trying to say. At the compile time, it assumes that this reference has an object. I mean, this reference is it assumes that this is an object at the compile time. Okay, and it look for the methods in this class only at the compile time. At the time of compilation, it assumes that okay, there is a method in this.
I mean, it is assuming that printable is in
Disp.
parent class only. Okay.
But at the
So at the,
runtime, this object will be created. This object will be assigned to D. Then it will try to access everything from the object. The only
so in a
varies.
way, during runtime, it will take the data members from the disk, whatever data members are there in disk,
No.
and
At the runtime, no. At the runtime, it will take the members from the child
okay,
polyprintable. At the
so
compile
data
time
members,
only.
data functions, all there.
Yes, all.
Okay.
At the compile time only, it look into this. That's the reason we'll call this is the dynamic polymorphism. Dynamically, it will getting changed. At the runtime, it is getting changed, not at the compile time. Got you? You got that?
Yeah.
Okay. So at the compile time, it look for this. At the
Ravi,
runtime,
can we do one more thing here, just to test the functionality? Can we have a variable defined in disk and try to access it
see
in
in
this
Scala,
polyprintable? Yeah.
in the Scala, variables can be overrideable. Variables can be overrideable. You try that assignment. You take that and try it. So in
Okay.
Scala, you can override the variables also.
Yeah.
You can override variables also, not only methods. But in Java, it
Yeah,
is
we have
not
seen
possible.
in. Okay.
So you try that. You'll understand. So this is about polymorphism and encapsulation. Okay, there is one more concept before we jump into the main part of collections and all. There is something called case class. Case class, another important one. Case class. Okay, this is really important. It's really important. Why? Because people will ask in interview, what is a case class? What is a case class? Okay, I'll just give an introduction of this and we'll stop here, and when connect next session we'll talk about the case class. Okay, so Scala has a special type of class called case class. By default, case classes are immutable and compared by the values. It's immutable classes. It's immutable classes. Once you declare a variables in that class, cannot be changeable. You can define a case class with the case class keyword. The difference between the normal class and this is case class are immutable and they are compared by values, variables inside this, and case classes are you really no need to use a new keyword. Another beautiful thing is look at here. Look at here. I have a point. Point is my case class. It has a x point, y point. It has a x point and y point. Okay, so when I have a x point and y point, when I have a x point and y point, and I'm creating an object, look at here. Did I use new keyword? Did I use new keyword?
No.
So case classes objects can be created without using new keyword. And the main purpose of the case classes, are to pattern matching. Pattern matching means the main use for the case classes are to match the things, because it will be compared based on the values. Internally it will compare based on the values, so you can easily do the matching. Pattern matching, you guys remember the pattern matching? Match case 1, case 2, case 3. You guys remember? In control statements we discussed, not control statements. Pattern matching only we have a separate session. The first session, pattern matching. You guys remember this?
Yeah, data types.
Here,
There is,
not only data type, he
yeah,
can
yeah.
use directly case class objects. Because it will compare based on the values. So you look at here, no, if condition I'm trying matching the values. Look at here. Okay, let me put in this way. I have a case class point. Okay, x variable, y variable. You guys know what is this represent? What is this represent, Rishabh?
Auxiliary constructor.
No. That is
Oh,
this
sorry,
with
the super class.
this with the brackets. It's auxiliary constructor.
Okay.
This with this
Uh,
bracket, it is auxiliary constructor. If I write like this,
so
this is
this
auxiliary
will
constructor. Current object.
be current object, yeah, and the
Current
variable
object
within the class.
x. Yes, current object. Okay, so this x and y am coming from the constructor. This x and y inside the class. This class variables. Constructor variables can you use outside. You cannot use, no. Constructor variables you cannot be used outside. So I'm declaring my class variables. These are my class variables. Fields. Do you guys remember fields? Fields, local variables, arguments. These are my class variables. Okay. So I have declared my object called point. One object. Second object is point. If I compare these 2 points, whether they have to be same or not. They have to be same or not.
It won't be same.
It won't be same. Let's see. Why it won't be same? Can anyone tell? Why it won't be same?
Because we are creating two different objects with the same class.
Let's compare it. Let's run the program and compare it. Case class objects are same. P1 equal P2. When I compare, case class object same. It means it's easy to compare. That's what I'm trying to say. The case class has a special behavior. They are immutable and compared by the values. They're immutable and compared by the values. Okay. Similarly, I have one more class. Look at here. Class point. This is normal class. Same x and y. Same x and y. Okay. Class point x and y. And I created objects for them. Class point 1, class point 2. Class point 1 and class point 2. Okay. Class point 1, class point 2. I'm comparing them. Class point 1 equal to equal class point 2. Class point 1 equal. So you tell me, is this true or false? I mean, is this will it be classes are equal or not? Classes are not equal. Look at here. Class objects are not same, but the case class objects are same. So if you create any object using normal class, they cannot be compared easily. They cannot compare easily by objects. Okay. Until unless you have override hash code equals, there are a lot of things. Hash code and equals you have to do internally. You have to override your own hash code and you have to override your own equals method. But a case class is not like that. Case classes by default internally hash code and equals are overridden and it's compared by the values. The case class objects are comparable by the values. Okay, is this clear? Try guys, do one thing. The same example you guys try, you will understand. So this is the most important. Case classes are most important. I don't know this definition. I want you to make a note or save somewhere. Okay, it is a by default immutable and compared by the values, and you really no need to use the new keyword to create the object. Why? Because internally it has an implementation called apply. There is something called apply, so that apply is already default will be considered. It will not no need to use the new keyword. It can automatically create objects. If you say that no sir, I will create with the new keyword, sir, I will create with the new keyword. Go ahead and create. Go ahead and create. Go ahead and create. So there is no harm. Okay. Case classes are. Go ahead.
Yeah. Okay, I have one question.
Go ahead. Your voice is not.
Yeah. So, actually, so what is the purpose of creating the case class? Means like we are defining one statement where we can create the object, and that object, if suppose if I'm creating 5 number of objects, so 5 are same only. Then what is the use of creating the case class? Like
You
in
don't
a
create a
given statement.
same. Don't create it with the same value. So what is the requirement of creating with the same value? See, I have an employee. Okay, I have an employee. Will be employee name is same, ID is same, salary is same, date of birth same. Like that, will I have multiple employees like that?
Okay, got it now. The use case of case.
We won't have, right? We won't have such kind of things. No, you got what I'm trying to
Yeah,
say? See, I have a class employee.
yeah.
I created like this. I have ID, name, salary, and DOB. Will you create objects like this? Name Ravi, ID 101, salary 100, date of birth is 21/10/20. Let's say 2020. Will you be having the same object like this with the other name, like here Veera? Now you tell me these two are same or different?
These two are different. I mean, with respect to
Java.
uh,
With respect to Java, these two are different. But in Scala, but actually you tell me, normally these are two, it looks same or not?
Yeah, it's same.
But Java compliance, no, these two are not same because you have created two different objects. I am creating two different memory locations and two different references. They are not same. But when it comes to Scala, case class, it will compare internal values. Ravi, 10101, 100. So when it compare all of, hey, so all of them are getting matched. So these two objects are same. That's what the case class does. Clear? Rishabh, if you have any
Yeah, Ravi.
confusion, please ask me
Mm-hmm.
because it's quite important. The case classes are quite important. So case classes will frequently use in Spark.
Okay.
Case classes are the special type of classes. It will be having immutable variables, and it is a comparer. It is a compared by value. It's compared by value. Okay, so that's the reason when I created two objects with the same data, when I compared it, it says equal. But when I created a normal class objects with the same data, when I compared it, it says not same. Okay, so this is more important case. So that's it for now. So if you guys have any questions, please ask me, else we can leave for the day. Any questions? So in the next session, we will be starting a new concept called exception. Exception, the most important, that one also, exception handling. So we'll discuss that, then we will move on. Okay, guys. Okay.
Yeah, Ravi.
Thank you,
Thank you,
Ravi.
guys. Thank you. Thanks for your time.
Yeah,
Have a
thanks,
wonderful day.
Ravi. Bye.